So good morning or afternoon, everybody. Welcome to our bi-weekly free seminar. And this seminar will demonstrate RoadEng with Softree Optimal for pipeline projects. And we'll be recording today's presentation. And we will email you a link to the YouTube movie, which you can forward to anyone who missed the presentation if you like. So just before we get started, a little bit about us for those of you who are new to Softree. We're based in Vancouver, BC. We're a civil software company, and we've been in business for over 25 years, and we have quite a number of clients. And our philosophy with software design is that we make our software easy to use, and we focus on engineering over drafting. We provide speed and power to handle large problems like LiDAR, and we're innovative. That's a little bit about us. And with that, I will pass on to Dave.
Thank you, Cam. Okay, today we're going to be talking about pipelines, and I'm just doing an optimization right now on a pipeline that is, from our experience, probably a reasonable facsimile of a large oil or dilbit pipeline. This is something we've made up on our own data. We don't want to, unfortunately, we can't show you some of our customers' data because we do have some real pipelines that our customers have been working on. The other thing that some of our customers are working on is Penstock Pipes. So carrying water in a run of river situation where you want to get the water up to a high point and then drop it down to a penstock, and that's what this other design is here. So I guess if you're familiar with RoadEng, you know that it's good for designing roads, and it's actually not bad for designing pipes. We're still learning. We're still adding features. One of the features we added recently was the option to display your grades as degrees instead of percentage. So you can do that in our module setup menu here. Slopes, we can change that to inclination, which is, of course, is in degrees. And so then when you display things like the grades of your design, let's see, that would be in my data window, one of them. Yeah, there's my vertical grade breaks. This one's got curves, so it doesn't have any vertical grade breaks, but the actual grades here are, oh, I'm not sure whether those grades are showing, it says inclination there, so I guess it's in degrees. Yeah, so let's take a look at the problem of designing a pipeline from square one. I've got a nice LiDAR data set in the background here. Let's take a look at that. So it's, of course, our terrain module where we build our surface models. And in this case, let me just open a file that has some proposed pipe center lines in it. So this is a fairly simple pair of alignments. I put them on the same surface. This one is your run-of-river penstock. This one here is your oil pipeline. And once you know more or less where you want to put them, we can actually import data in such a way that we don't need to import all of the LiDAR. So I've probably demonstrated this a few times, but just go over it quickly. If I have a couple or many LiDAR tiles, when I import those files, I have an option to select by polygon or by corridor. So in this case, corridor would make sense, and I could say, okay, there's my pipe. I want that pipe to be the area where I have dense data. Let's make the width 100 meters. And now, when I read in my data, the pipe comes in with 0 skipped. I'll set the default up to skip a bunch of points so I don't have to clog up my computer with large numbers of points, and let that run. Now, okay, are we in the reasonable coordinate system? Yes, so I'll just let that go. This takes a little while to read in two large LiDAR data sets. I think the two tiles have around 4 million points each, so it takes a little bit of time to read it. If you had 10 or 20 tiles, it would take even longer. But the good news is that you only have to do this once, and then you've got a terrain that is usable for multiple purposes. Okay, so it's finished bringing in the data, and notice what's happened here. We've got dense data near my pipe, and then not so dense data outside of the pipe. And the total number of points now is it's only 450,000. As I mentioned before, if I brought them both in, it would have been around, well, I guess 4 million for the total, maybe 2 million for each tile. Okay, well, I've already got that on the hard drive, so I don't need to save this. But the great thing about LiDAR data is that you can move your alignment around a lot, and you're still dealing with real stuff. So let's say, for example, I wanted to create a new alignment somewhere. And this, of course, works for roads and, oh, I'm getting a reasonable value for my optimality gap. Just an aside, I've got this optimization going on in the background. So if I were to, let's open this one, make sure it's saved, and start a brand new alignment. So in RoadEng, when you start a new alignment, the first thing it does is, come on. Okay, there must be a message box here somewhere. Sometimes they pop up on the other screen. Here we are. When you create a new alignment, the first thing it asks you for is your original ground. So there's my original ground. This is the one that has the dense data near the pipe. It doesn't particularly matter because even when it's thinned, it's pretty good data. So I can use this terrain. If you have a feature that represents your center line, then you can start by using that feature. You can also bring in land XML. So if you've got a land XML representation of the center line, you can start from that. I'm just going to start from scratch because I'm going to start in the middle of the terrain and just start designing an alignment. So what kind of alignment am I designing? Let's say I want to work on designing that penstock. So where the heck is it? It's I'm going to put the pipes in the background so I can see it properly. And you know that properties for backgrounds can be washed out depending on what you want to look at. So the pipes I want to see in their full dark color. There we go. So there's the proposed run of river. The river itself would be down in the valley here, and this is where the penstock's going to go. And I already drew this in while I was playing around with it this morning, so I could be quicker during the demo. But here's the concept. Let's say we don't know where we want to go. All we know is that we've got a proposed power station down here, turbine, and that we want to leave the river from a weir up in the valley here. So I'm going to make a new alignment. I might as well start with the template that I want to use. So I'll put the penstock template in. That's what it looks like. I'll put that in as my template everywhere. Oops, wrong. Oh, no, that's the right one. So I want to put the penstock template everywhere. There we go. Okay. Right. So I'm going to start. Whoops. I've already started. There's a point on this alignment way up here. So let's drag that point down to the area where I want to start and put it roughly in the right spot. Okay, there's my starting point. Now I want to move along down here, and as soon as I create a leg of my alignment in the plan view, I'm also creating a little piece of profile. But I'd like more information, so I'm going to go into a different screen layout. Screen layouts allow you to set up all the different options with the click of a button. So you know, I know how to use the software. I know how to set up all the options I would need for various tasks. But if I were somebody who was a little bit unfamiliar, I could just say, oh, my colleague set up a screen layout for me. It's called pegging. I'll just use that. And the screen layout sets up all the options I want. Notice now that it says that the grade between these 2 points is 4.1%. Well, my penstock should probably be going downhill, so I'll move that down a little bit. Oh, now it's minus 9.2. Let's go up a little more. How about minus 1%? That looks good. And I can keep doing that and move along the alignment or the proposed pipe. Do you call it a right-of-way when it's a penstock? I don't know, the proposed right-of-way. And just make sure I'm going slightly downhill by putting in these points here. And as I do that, you can see the profile is being created. Now, you know, it's pretty bumpy. If I don't like this little dip here, for example, well, watch this. There I can see in my plan view. Now, remember, we're working with a really cramped screen here, and so everything looks a little bit cramped. But with 2 monitors or with a big monitor, this stuff works really nicely. So I just hover my cursor over the dip, and I see the shadow cursor moving in the plan. Similarly, if I move around in the plan, you see a shadow line moving in the profile. So it's right about there that I've got that big dip. So I'll just create a new point, move it up, and now I can see that, oops, that's 8%, and that's 24, minus 24. Okay, I went up way too high. So I'll go down a little bit until I get 2 negative numbers. There, they're both negative. That's good enough for me, and I've taken that little dip out of the profile. So that allows me to kind of track the ground. Let's just bang in a couple of points quickly and get on to the next stage. Up too low, minus 9, minus 7, 2, minus 0.8, that's good. And then let's take our plunge at minus 47% down to the powerhouse. This is not a very realistic penstock because it's only 300 meters long, and the big drop is only 20 meters of head. You're not going to get a lot of power out of that, but you get the idea. By the way, if anyone has a question, feel free to type it into the questions area, and I'll try to notice and let you know the answer, let everyone know the answer. Okay, so I've got a decent profile here. Now I can start designing it. And of course I can do this by hand, but we want to show you the optimizer. But let's just quickly do it by hand, see how it works out. I'm going to put in a grade like so, and another one down like that. And I like the 2 endpoints because I've designed them properly. I got a negative grade there. I do have some areas where there's fill. That doesn't look like a very good spot to put a pipe. You can see in the cross section there. So what should I do? Well, I can lower everything down, or I can move horizontally. Now, we don't have a horizontal optimizer yet. So when you're dealing with a situation where you're probably going to be doing some horizontal alignment, what you can use the optimizer for is to quickly generate vertical alignments for you for every horizontal that you make manually. So in this case, I might want to move that point there uphill a little bit, right? Okay, those are both negative. That point is now closer to the ground. This isn't so bad. Similarly, I got a bump here. Let's move that one downhill a little bit. We want to track the contour more, right? And yeah, that looks okay. One more bump I don't like, this one here. That's way over here. Yeah, okay, let's just track the contour a little better. Okay, now I've got a horizontal alignment that I'm pretty happy with. Let's see what the optimizer can do with that. Okay, I'm just going to save this so that I can come back to it later. And got a nice screen layout that's set up for our optimizer. So here comes the first vision of the optimizer. How are we doing for time here? Yeah, that's about right. Okay, so this panel is the alignment properties panel. It's where you do all your optimization work. It's part of the window menu, as are the other panels. And you can see I've got vertical curves, culverts. It's very similar to those other panels that are part of RoadEng and have been for a long time. Yikes, that doesn't look very good. What am I going to do to optimize this? Well, here's how you do it. We go into the options. By the way, this is a hand design. I kind of like it. Let's make a new design so we can do comparisons. So this one will be optimized. And there's various things you can do to tell the optimizer how to work. First of all, how far above and below the existing alignment are you allowed to go? 10 meters seems reasonable. I'm going to leave it at that. What kind of spacing do you want? I'm just going to pick a number here, 10. But there's a way of choosing the spacing, and I'll show you that in a sec. Then what curve standards do we have? Now, on a road, you know, this is all about site stopping distance and vertical curves and so on. For pipeline, grades are pretty important in the penstock. We want it to be negative, but we don't really care how negative. We certainly don't want it to be positive. So let's say it must be below minus 0.5. And now curvature. How are we going to deal with this? Well, the simplest way to deal with it is to put in a polyline so it looks like a bunch of pipes stuck together. So I'm going to do it that way. You can also use curves and imagine that it's an approximation of a bunch of pipes stuck together. And let's make the pipes 10 meters long, same as my sample length. And finally, how much can we break between the pipes? And when you're dealing with constructing pipelines, I'm told, I'm still learning about this stuff, that there are field bends that you can make relatively cheaply in the field. They would be a small grade break. Unfortunately, this one doesn't work in degrees, so if I wanted this to be, for example, 2 degrees, I would type in 3.5%. And, whoops, this didn't get changed. How come? I wanted that to be minus 100 and this one to be minus 0.5. There we go. Okay, control points. We want this thing to start at the existing alignment. There we go. And we want it to end at the existing alignment. Oops. And that elevation is automatically picked up from the alignment. So the hand design that I just did is setting these two values. So we're going to match the hand design at the ends. Other constraints? Well, this is a pipeline, so why don't we specify a minimum cut of 0? In other words, we can have the center line. I don't know where the pipe sits actually. Is the pipe on the center line? I think it is. So let's say it has to be a little bit down. Let's say 1 meter below ground. This may be a problem because our starting point is not below ground, and indeed that's what we're getting here. Okay, so let's change those control points. That's a pretty handy tool. The conflict tells me right away I've got a problem. So I'll go back to my control points in here, and I'll just change the elevation down by 1 meter and do the same thing here. And that doesn't get rid of the conflict. Oh, still there at 368, which is the first one. No, the second one. Okay, let's go down a little more. How about 0.5 there? There we go. Okay, done. And again, I'm going to save this. And now let's let the optimizer find a solution. Quick feasibility is turned on. That means that if there's something grossly wrong with the geometry, it'll find it really quickly and tell me to stop. We're probably going to build that in as an automatic feature, but for now it's explicit. And then I'm going to do my optimization. Okay, let's go. So the first thing it has to do is calculate a whole bunch of cross-sections. And those cross-sections are sampled above and below the existing alignment. In this case, it's my hand alignment. And then it uses that information to go away and do the best vertical alignment it can find. And in this case, it didn't take very long. Oh, no alignment could be found. That's interesting. Okay, I'm going to loosen up something and see if we can find an alignment. So how do I do that? Well, let's loosen up the minimum cut constraint. This is fairly sophisticated part of the software. Most of the time you won't be dealing with things like this. But often when you get a situation where the software can't find a solution, it makes sense to turn off a constraint. And the technical term for that is to soften the constraint. It's not really turned off. It's still there, but you're allowed to break it. And you'll notice over in the profile window that it's actually showing me where I'm allowed to put my alignment. And look where the existing alignment is here and down there. I'm thinking that maybe the problem is right at the end here. And actually this softening the minimum cut thing is going to cause it to go above ground in this zone. Okay, let's see if that's the case. So I will process. We are in view line 2, right? Yeah. I don't have to pre-process, which is nice because I haven't changed anything. So it goes very quickly into the optimization. Oh, it found a solution. And it's now looking for a better solution. And if it doesn't find one quickly, oh, it did find an optimal solution. However, because I softened my cut constraint, we've got some violations. And you can read them, but it's probably just as easy to look. Let's set this alignment current. And there's my alignment. And you can see here my cut violation is broken. And we've got a gentle curve through this zone because I told it that it could only go at 2% per pipe. And if we actually look at that, data number 1, there, oh, it wasn't 2%, it was 2 degrees, so 3.5%. There you can see that there's no grade breaks bigger than that. Okay, that's enough of that. I wanted to also show you the other pipeline, which has a really fancy template in it. We've got about 5 minutes to go. Any questions? Before I carry on, just notice here that under standards, I can put in a station range. So I could actually say, you know, I'm using field bends here everywhere, and I end up with this curve, right? It's a gentle curve. Why don't I put in a factory bend at the corner there at station 292 so that it will not have so much cut in that zone? And yeah, because you can see from the cross section there that we're way underground. You know, there's a lot of cut there. And that can be done right here. I can just go into my, let's create another design. Oops, caps lock. So under standards, what I would do is say, okay, well that station was 280, so let's put in a station range here, say 270 to 290, 20 meters, where I let the grade break be a lot bigger. And there we go. So we got three ranges. We got the factory bends up to 270, anything you want up to 100% at 290, between 270 and 290, and then it carries on from there. And I'm not going to run that just now for two reasons. The first one is that I actually couldn't find a solution. But the second reason is that we're running out of time, and so we're still working on making pipelines function really well in RoadEng. And like I say, that particular little trick should work. It didn't work for me this morning, so we're going to look into that and see if there's a problem. Could be just the way I implemented it. Now let's go back to the oil pipeline. Okay, this is fairly typical of a long alignment. It's already been running for 1,600 seconds, and it has not found a solution yet. The little I there means something, and I've forgotten what it is, but it's telling you that so far the lowest cost solution it has found is this number. What is that, 1.2 million? If I'm counting digits correctly. No, it's 12 million. Okay, that's expensive. It's found a solution, but it may find a cheaper solution. In fact, it's possible there's a solution that's 9% cheaper. But that is the upper bound of the possibilities. We may have actually found the optimal solution, but we don't know that for sure. Anyway, I'm willing to stop now just for the sake of showing you what we found, but probably realistically you'd want to let the optimality gap get a little smaller before you stop. But let's just see what it looks like. So I'll cancel that, and it's going to show me the alignment that it created. Notice there's no alignment on there yet. By the way, there's a glitch in here. The cost optimization is not working, but it will work if I just rerun it. So I'll just do that quickly. By the way, I'm not running the release version here. I'm actually running a test version of the software for the release that's coming. The one on the web is missing a few of the features that are being tested right now. Yeah, so if I just do a quick recost, it will work, and it will come up with this graph here, which is showing me how the material is moving around. Now, what I did in this particular one is, let's just look at the options. I did put in a special station range here where it's allowed to put in a sharp curve, and you can see that here. The first solution, oh, it's not displaying. That's interesting. First solution's not displaying. Okay, that's a new glitch in the software. Used to be you could look at two alignments at the same time, which was very useful. Now to actually look at the first solution, I have to set it current. Anyway, we'll just do that quickly. And oh, okay, there is no first solution. That would explain it. I'll just have to tell you what it looked like. But the second solution that I've gone through here works really nicely, and you can see that most of the place it's doing really smooth curves, but then I've got this sharp bit here because I put in a station range where I was allowed to put in sharp curves, or factory bends, if you like. What is the optimizer giving me here? Well, first of all, it's giving me a fairly instant alignment. I mean, it wasn't totally instant, but I could go and make myself coffee meanwhile while it's doing its work. So I've got a profile. It's telling me what my mass haul is going to look like. And it turns out we need to borrow some material. I think that's a borrow pit. No, it's a waste pit. Oh, okay. And mostly it's balanced, which is interesting. This is balanced because of a special template we came up with. Let's see if we can see how it works here. There we go. So one of our customers said that, well, you know, in steep ground with a pipeline, you have to have the pipe under the ground, or at least the center line of the pipe has to the center line of the road where the pipe exists has to be under the ground. Here it's well under the ground. And so you often end up with a lot of cut. And the problem is, how do you get rid of it? So what we did is we created a template that would get wider whenever it was possible. Let me show you that. So here's our special widening template. So if I'm here, you can see the template's quite wide. But if I go up enough, it gets narrower. Is that catching up on your screen? And why does it get narrower? Well, I actually told it that I'm not allowed to have a fill depth of more than 50 meters. 50 or maybe 60. It's 56 there right now. So if I raise the thing up, this offset now is my minimum offset, which is 15 meters. 17? 16? Okay, whatever. That's my minimum offset. Then, if I lower this down so that my fill height is not so big, it adds extra. And now my offset to the corner there is 67 meters. It just adds extra to put more fill in. So it's kind of a maximum fill template within your specification. So you specify how far out it's allowed to go, and you specify how big the fill is allowed to be. And it will just try and maximize fill. So with that template, the optimizer was able to generate a profile that actually balanced the material. So there's no need for a waste pit. It's just expanding the template wherever necessary or wherever possible to accommodate the fill. And you can see where it's doing it. There's a spot. There's another spot. These dashed lines here are the total fill. Well, that's kind of all I wanted to say. The optimizer is minimizing cost, so it is important what unit costs you put in for your material and unit costs you put in for hauling. That's the kind of thing you work out by trial and error, and we've got some good results from some customers and from some research we've done. So these numbers don't come out of thin air. And I guess the next thing I want to point out is that once you've created a horizontal alignment, you can generate the vertical automatically. So that means that if you need to change your horizontal alignment, you don't have to spend as much time determining what the vertical is and determining what the cost is. You can just use a well-defined set of options to generate a vertical, take a look at the cost, make a new location design with a new horizontal, and do it again, and you now know which one is better by the cost. So it's a quantitative, reproducible way to cost a horizontal alignment. You know, it may not produce the perfect vertical, but if you set your constraints and options reasonably, it will produce something that is reasonable and therefore comparable. Any final questions before we pack it in for the day? Okay, thank you very much, and On behalf of Softree and Canada, thanks for watching the web presentation. We'll have another one up in a couple of weeks, and this recording should be available in a couple of days. Bye now.